Hey guys, all right, we're going to talk about notes 3, laws of logarithms. So there's different things that we can do to simplify logs and get answers a little quicker. So there's these three properties that you do have to know. And the first one is if you have log base A of, a product. That's really what we have here is we have our product. So if you have a product with the same base, you can separate those into an addition problem. Okay, so we're going to be doing a lot of expanding and condensing. So the example that I'd like to use is if we had log base 2 of 3x, we could expand this and say log base 2 of 3 plus log base 2 of x, and vice versa. If we had the addition problem here like we do, we could combine it into multiplication. So these work forwards and backwards. So the next one is if we have a quotient. Okay, same base, but we have a quotient. So we'd have log base of the little a subtracting log base a of b. So using kind of the same example that we had, I'm going to put 3 over x with the base 2. So all that means is that we can separate log base 2 of 3 minus log base 2 of x. And whatever's on top is what goes first, and what is in the bottom goes after the minus sign. So if we were trying to condense this and put it back into a quotient, that's the rule we would follow. So then the last one is when we have a power, okay, log base a of some base raised to the c. So what that means is we can pull the exponent out front. So c times log base a of big A. So my example is if I had log base 2 of x to the third, what that means is I can pull that exponent out front. Okay, it would go out front and multiply with the log. And so you have log base 2 of x now. Okay, and we're going to do a lot of examples like that. And you can do this forward and backward, but these are the three properties that you have to know so we can expand and condense our expressions. So for the examples that we have example A, we have log base 4 of 2 plus log base 4 of 32. We have addition here. So that means that we can combine using multiplication because they have the same base. Okay, make sure they have the same base. So we can say log base 4 of 2 times 32, which gives me log base 4 of 64. And we're not done there because now we can go and simplify. So I know from the list of multiplication that I was asked to memorize that if I'm trying to simplify my log and it's base 4, 64 can be broken down into 4 to the third. And from the properties we learned in the other video, if I have log base 4 and an exponential with the base 4, these cancel, and what's left is the exponent up top. Okay, so my answer here from the expression we had is 3. So for B, we have subtraction, and we have same base. So that means we can rewrite it as 80 divided by 5. So log base 2 of 80 divided by 5 is really log base 2 of 16. You have to simplify. The whole point of doing this is to simplify. So if you combine them, if you combine your logs and then you don't do anything with them, you haven't done anything at all. Okay, we need to make sure that we know how to simplify and manipulate these expressions. So then I know that 16 is a base 2. So if I have log base 2, I can convert 16 to what it would be in base 2, which is 2 to the 4th, because remember I gave you that laundry list of exponents you had to remember for 2s, 3s, 4s, some 5s. So you do need to know a lot of these. So 16 it can be substituted in for 2 to the 4th. And just like our last one, if I have an exponential base and a log base that are the same, those cancel, and what's left is the exponent. So here it is 4. My answer here is 4. And for the last one, the last example that we have negative 1/3. So we have negative 1/3 times log, and I want you to add this base 2 of 8. Okay, so the base wasn't there, so please put the base 2 in there. So what we have from our properties is we have this coefficient out front, which means we can pull this into the exponent spot. Okay, so when we pull it into the exponent spot, we have log base 2 of 8 being raised to the negative 1/3. And so whenever you're doing your logs and you're trying to simplify, you need to see what the log base and the exponential base has in common. So just like we did for examples A and B, we changed our exponential base to whatever the log was, and here it's been base 2. 8 can be converted to a base 2 because 2 to the 3rd does give me 8. This is something you guys do have to know. You have to be able to convert back and forth. So we're going to switch 8 to 2 to the 3rd to the negative 1/3. Okay, so here from our exponent properties that we learned, we know that if we have parentheses being raised to an exponent, we know everything on the inside gets raised to that same exponent. So I can distribute this negative 1/3 into the parentheses and simplify the exponents before I do anything. And that's exactly what you should do. So now we have log base 2 of 2, and now we need to decide what our exponent is. So 3 times negative 1/3, you guys know this cancels to negative 1. 3 cancels with 3, so 1 times negative 1. This new exponent is negative 1. And just like the previous problems, my exponential base and my log base are the same, so those can cancel. So my answer here is actually negative 1. So this is how you should approach those problems. This is the process that you need to take. We need to convert between bases. We need to make sure we're applying our exponent properties that we talked about and go forward. So we're going to use these ideas to help us expand and condense. So we can take our logs and we can break them apart and put them back together. So for example, using the properties of logarithms, we're going to expand each expression. So just like we did in the examples on the last page, we're going to apply what we know. So for example A, we have log base 2 of 6 times x. We do have multiplication, so that means we can break down into an addition problem. So we should be able to write log base 2 of 6 plus log base 2 of x. And now if this first log can be broken down, then we need to break it down. Unfortunately, 6 does not break down to anything, so this is completely simplified. 2 times 1 is, or 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. We can't get 6, so we can't change it out. So this is completely simplified the way it is. But you should always be asking yourself those questions. All right, so for example B, we have several things going on here. So you can see log base 5 of x to the 3rd, y to the 6th. So the first thing that I want to take a look at is the multiplication. So I'm going to change that to an addition problem. That's the first thing I'm going to do. So log base 5 of x to the 3rd plus log base 5 y to the 6th. And then the second thing I'm going to take a look at are these exponents. Okay, you can't leave those there. That's not completely simplified the way it is. So we're going to take care of our exponents in our second step. And if you recall from the property we just talked about, all these exponents can be brought out front of the log, brought out in front of the term as a coefficient. So now we have 3 times log base 5 of x plus 6 times log base 5 of y. So now if these terms in this expression could be simplified in any way, then we need to continue to simplify. But we just have variables, so we don't need to worry about that now. So moving on to part C, we have natural log a times b in the top divided by the cube root of c. So we have a few things that we can take a look at here. So the first thing I want to take a look at when you have a problem like this, I would take a look at the division. And if you recall, division means you're subtracting. Okay, our division is right here. So we're going to take our natural log and split up the division. So natural log of AB minus the natural log of the cube root of C. So then the second thing I would take a look at is now your multiplication, which if you remember is also addition. So we're going to take this multiplication of AB and we're going to separate it into natural log of A plus the natural log of B minus the natural log of the cube root of C. So then we have one more thing that we can do, and we need to take a look at any exponents that we have. So really, because you have 3 properties, you should be checking to see how you can separate the 3 properties each time, whether they're in the problem or not. How can you apply them throughout the problem if they're there? So the exponent that we're going to look at is actually the cube root of c. So when we talked about exponents at the beginning of the year, we could say that a cube root could also be written as 1/3. Okay, so if this cube root could be written as c to the 1/3, then this cube root right here could also be brought out front of our term, and that property that we just learned of bringing the exponent out can be applied. So now we have natural log of a plus natural log of b minus 1/3 the natural log of now c. And that's simplified. If we had numbers or if we had an e or something, then we would need to take care of that. So then when we're combining, that was expanding. Now we're going to pull it all back together. Okay, so example 3, we have combined 3 times log of x plus 1/2 log of x plus 1 into a single logarithm. So you can see that there's no base listed here. Remember, when you have no base, it's log base 10. It's the only one that you don't have to write. So there's a few things that we can do here. So when we're working backwards, look at how you can apply your steps. So the first thing that I want to take a look at if I'm working backwards is I'm going to look at my exponents, okay? From what we just did in expanding, exponents was the last thing we took a look at. So when you're going backwards and combining, it should be the first thing you look at. So exponents, I have this 3 that can be brought up, and I have this 1/2 that goes to this entire group in the parentheses. So now I should have log, and we don't have to write the base 10, but log of x to the 3rd plus log of x plus 1 to the 1/2. Okay. So then the second thing I need to take a look at is if I have any multiplication or division. So if I had any multiplication or division, this is where I would do it. You could do it in just one big step. Here I just have addition, which means I have a multiplication problem. So now I'm going to take what I wrote, so log base 10, and I'm going to combine it. So x to the 3rd times x plus 1, that whole thing being raised to the 1/2. And if you could simplify, you should simplify. Here, all this really says is the square root of x plus 1. Okay, and because it's multiplying the x cubed, you can't simplify either of them. So either of these answers would be sufficient for me. Okay, so moving on to example 4, we have a few things that we can do. We've got combine, and then we've got 3 times the natural log of s, that is an s, not a 5, plus 1/2 natural log of t minus 4 of the natural log of t squared plus 1. So again, the first thing that you should take a look at is your exponentials. So 3 goes up into the power for s, 1/2 goes up in the power for t, and just this 4, okay, not the negative, goes up in the power for the group over there. So we're going to write natural log of s to the third plus the natural log of t to the 1/2 minus the natural log of t squared plus 1 raised to the fourth. Okay. So now we're going to look for if we have any addition and subtraction that we can convert to multiplication and division. So we actually have both here. We have this first group is being added, and so that means we can multiply them together. And then this last group is being subtracted. So remember, whatever is after the subtraction symbol goes in the bottom of your fraction. So we're just going to do it in one big step because I think that's a little bit easier for you to see. So we have the natural log, and then we're going to have a fraction. And I know that when I combine, the natural log of t squared plus 1 raised to the fourth is going to go on the bottom because of this subtraction symbol. So that goes down there. So then in the top is this multiplication that I need to simplify up here, this s cubed plus t to the 1/2. So really what I have here is s cubed times t to the 1/2 with the natural log on the outside. So that's exactly how you would write it. I don't want to see natural log over natural log. That's not simplified and not correct. So you should have your natural log on the outside with the whole thing associated with that natural log. Okay. So the last one I want to take a look at on this page is this combining log base 5 of x squared minus 1 minus log base 5 of x minus 1. So we don't have any exponents here, which is the first one we would take a look at. So the second thing we need to take a look at is if we have any addition or subtraction. So we actually don't have any addition or subtraction. Or addition, we do have subtraction, I'm sorry. So we are going to take our log base 5, and we are going to combine our logs. And remember, whatever's after the subtraction symbol goes in the bottom, okay? And then whatever's in the front of the subtraction symbol goes in the top. So here, oops, that's not a plus, that's a minus, so change that really quick. So here, you're not done yet because if you look, we have a top that is difference of two squares. So we haven't really done any simplifying yet with any of the examples, but we've talked about that if you have it, you need to simplify. So this is where we're going to begin that process. So this log base 5, really in the top you have x plus 1, x minus 1, and then in the bottom you have x minus 1. So we need to take a look at what we can simplify when we factor. And we actually have x minus 1s that we can cancel because we have 1 in the top and 1 in the bottom. So when we do that, we end up with an answer of log base 5 of x plus 1. And that's our final answer for that one. So a lot of our factoring and exponent properties, a lot of that stuff is going to come back, and we need to make sure that we understand that how to apply them. So we have change of bases next. The video is getting a little long, but this is the very last thing we need to talk about, so I apologize. So change of base, if we don't have a calculator, this is how you would do it. Here's our lovely little formula. So if I asked you, you had to change your base so you could simplify without a calculator, this converts a non-base 10 into base 10s. So we're going to use this formula to convert from a number that isn't 10 to a base 10. I'm going to show you what that looks like. So you have to know that formula, make sure that you can apply it. So we're going to change log base 8 of 5 into base 10. So log 8 of 5. So now we're doing this in base 10, so this is our a right here. So log base 10, okay? 5 goes up top, and log base 10 of 8 goes in the bottom. Okay, so this is how you would write it. I would give you numbers that would simplify a little nicer here. So at log base 10, you could simplify and do more algebra. But if you understand how to plug it into the formula without a calculator, this is what you would give me. In the calculator, it does it for you, and you get approximately 0.77. So if we're doing example 7, we're changing log base 9 of 20 into a natural log. So we can also change into a natural log, and we can do this the same way. So log base 9 of 20, natural log of 20 divided by the natural log of 9. And you would leave it like this without a calculator, but with a calculator, you would give me the answer, which is approximately 1.36. Okay. I'm going to have you do these 3 practice problems on your own without a calculator, just so you can apply the formula and see what that looks like, and that'll be the end of the video. Okay, so go ahead and do A, B, and C now. All right, so this is what you should have for each of them. Really, you're just changing it into base 10. That's really all I care about. But if you know how to do it into the natural log when it states that, that's perfect. And then if you checked your work in the calculator, these are the approximate decimals that you should get. And again, the calculator will do it for you, and we can talk about that in class. Let me know if you have any questions. Have a great day.